Imagine drifting beyond the bright architecture of the Milky Way, past rivers of stars and the glowing cities of distant galaxies, into a region so vast and so empty that it seems to defy the design of the universe itself. Here, in the direction of the constellation Boötes, lies a cosmic abyss nearly 330 million light-years across, a hollow in the grand web of creation so enormous that if our own galaxy were placed inside it, the night sky would feel almost barren. It is called the Boötes Void, and for astronomers it is not merely a gap in space, it is a wound in the map of reality. The universe on its largest scales is not random chaos. It is a colossal structure, a cosmic web woven from filaments of galaxies, dark matter, and gravity, stretching across unimaginable distances like luminous threads over a black ocean. Everywhere we look, matter gathers into clusters, walls, and superclusters, while between them lie emptier regions known as voids. Yet the Boötes Void is different. It is not simply empty. It is shockingly, unnaturally vast, a silence so deep that even the mathematics of cosmic structure seems to pause before it. When astronomers first identified this region in 1981, the discovery felt almost absurd. The known universe was expected to contain emptiness, yes, but not emptiness on this scale. A handful of galaxies were found scattered inside it like lonely islands in a dark sea, but nowhere near enough to explain the size of the void. It was as if a giant section of the universe had been erased, leaving behind only fragments of what should have been there. That single realization transformed the Boötes Void from a curiosity into one of the strangest locations ever observed. Why does this matter? Because empty space is never truly just empty space. In cosmology, absence is evidence. A void this large carries clues about the early universe, the behavior of gravity, the hidden influence of dark matter, and the way matter itself assembled after the Big Bang. To understand what is missing from the Boötes Void is to ask whether our models of the universe are complete, or whether some deeper force shaped this abyss long before galaxies were born. This void is not only a place, it is a question written across hundreds of millions of light-years. And the scale of that question is honestly just staggering. Light, which, travels faster than anything else in the universe, would need hundreds of millions of years just to cross it. Civilizations rise and fall in like a blink compared with such distances. Human history is nothing here. Even stars feel temporary. So, what could create a hole this immense in a universe built to form patterns? Was the Boötes Void born from ordinary cosmic evolution, or is it the fossil of something stranger, older, and far more profound than we yet understand? To understand the Boötes Void, scientists had to stop thinking of the universe as just a scattered collection of galaxies and begin seeing it as a structure shaped by gravity over billions of years. After the Big Bang, matter was not distributed perfectly evenly. Tiny fluctuations, almost unimaginably small, were imprinted into the newborn cosmos. Over time, gravity amplified those slight differences. Dense regions pulled in more matter, growing into galaxies and clusters, while less dense regions lost material to their surroundings, becoming emptier and emptier. In that sense, a cosmic void is not carved out like a tunnel. It is drained. This idea changed everything. The Boötes Void was no longer viewed as a simple absence, but as the result of an immense migration of matter across cosmic time. Computer simulations showed that as the universe expanded, matter naturally streamed toward dense filaments and superclusters, leaving behind hollow regions between them. These voids could grow, merge, and evolve, like bubbles forming and pressing against one another in foam. The cosmic web itself emerged from this process, with voids helping define the architecture of the universe just as much as galaxies do. Yet the Boötes Void remained, honestly, pretty startling. Its sheer size really pushed the limits of what astronomers expected from standard structure formation. Surveys of galaxies revealed only a sparse population inside it, confirming that this was not just, a trick of observation. Even in a universe shaped by gravity and dark matter, such a vast, underdense region seemed, extreme. That forced researchers to investigate the invisible ingredients of the cosmos more closely, especially dark matter, the unseen mass whose gravity guides galaxy formation, and dark energy, that mysterious driver of cosmic expansion. The science here became a detective story. By mapping the positions of galaxies around the void, astronomers could, infer how matter flowed in the distant past. By comparing those maps with theoretical models, they tested whether the laws of cosmology could actually reproduce such an abyss. Some studies suggested the void may have formed from the merging of smaller voids over billions of years, gradually creating one giant emptiness. Others explored whether unusual conditions in the early universe might have seeded a region with far less matter from the very beginning. Inside the void itself, the few galaxies that do exist offer some pretty rare clues. They tend to be isolated, shaped by quieter histories than galaxies packed inside clusters. Without frequent collisions or strong environmental pressure, they preserve evidence of how galaxies behave in, cosmic solitude. In this way, the Boötes Void is not merely empty territory, it's actually a laboratory where scientists can study what happens when the universe leaves matter almost completely alone. And still, after decades of observation, one unsettling truth remains. The equations can describe how voids grow. Simulations can recreate large empty regions. But when we stand before the scale of Boötes, the question deepens again. Did ordinary physics create this silence? Or are we seeing the edge of something our understanding still cannot fully explain? The Boötes Void is often imagined as a place of absolute nothingness, but that picture is not entirely true. Even here, in one of the emptiest known regions of the cosmos, a few galaxies survive. And that is what makes the void so fascinating. It is not a clean hole punched through the universe. It is a haunted wilderness, a dark expanse with rare islands of light, where the rules of cosmic life unfold under conditions almost impossible to find anywhere else. In these lonely galaxies, astronomers glimpse forms of existence shaped not by crowding, collision, and chaos, but by profound isolation. Most galaxies in the universe grow through interaction. They tug on one another, collide, merge, exchange gas, and trigger bursts of star formation. Entire generations of stars can be born because two galaxies pass too close together. But inside a great void, such encounters are rare. A galaxy may drift for immense spans of time without a major disruption, evolving in near solitude. That makes void galaxies strange by comparison. Some contain large reservoirs of gas, quietly preserving material that in denser regions would have been stirred, stripped, or consumed long ago. Others continue forming stars in unexpectedly calm conditions, like candles burning undisturbed in a cavern of darkness. This is where nature becomes more ingenious than we expect. In dense clusters, galaxies are sculpted by violence. In voids, they are sculpted by absence. Their shapes, chemistry, and star-forming histories can reveal how much of galactic evolution is driven by environment and how much emerges from internal processes alone. Scientists have found that some void galaxies are bluer, less chemically enriched, and more slowly evolved than their cousins in crowded regions. They are not primitive in the simple sense. They are different, cosmic organisms living in a habitat where the usual pressures of survival are almost missing. And yet the strangest phenomenon may be the void itself. In a universe where gravity relentlessly gathers matter, how does such a colossal underdensity endure? Why did matter drain so efficiently from this region, leaving behind only a sparse scattering of galaxies? The answer may lie in the way voids expand. Unlike dense regions, which collapse inward under gravity, voids effectively push outward as surrounding matter is drawn away. Over billions of years, they become emptier and larger, almost like negative structures growing in the fabric of the cosmos. The Boötes Void may be an extreme expression of that process, a place where emptiness became an active force in shaping space. Recent observations have also suggested that galaxies near the boundaries of voids can align along filaments and walls, tracing the invisible skeleton of dark matter. That means even emptiness has structure. It is bordered, stretched, and defined by forces we cannot see directly. The void is not chaos. It is architecture made visible by what is missing. In the end, the Boötes Void reveals something astonishing. Nature does not need abundance to create wonder. Sometimes the most extraordinary adaptations, the most revealing scientific clues, and the deepest cosmic insights appear not where matter gathers, but where almost nothing remains at all. The Boötes Void is more than a curiosity on a cosmological map. It changes the scale of our questions. When we look into such a vast region of near emptiness, we are forced to confront a humbling possibility. The universe is not only stranger than we imagined, it may be structured by absences as much as by presences. Galaxies, stars, planets, life itself still may owe their existence not only to places where matter gathered, but also to the enormous voids that helped shape the cosmic web around them. In that sense, emptiness is not the opposite of creation. It is part of creation's design. This has profound meaning for Earth. Our planet exists inside a universe whose structure emerged from a delicate balance of gravity, expansion, dark matter, and time. The same processes that created superclusters and star-filled galaxies also opened immense chasms between them. Without voids, the large-scale architecture of the cosmos would be different. The rivers of galaxies that ultimately gave rise to stellar systems, heavy elements, and habitable worlds may have formed as they did partly because vast empty regions expanded around them. The Boötes Void reminds us that what appears barren can influence everything that follows. It also touches one of humanity's biggest questions. How common is life in the universe? If cosmic environments can vary so dramatically, then the story of life may depend on far more than planets orbiting stars. It may depend on where a galaxy sits in the cosmic web, how often it interacts with neighbors, how quickly stars form, and how elements necessary for biology are forged and distributed. In that broader view, studying voids is not only about emptiness, it is about the conditions under which complexity becomes possible. Some scientists have even wondered whether understanding vast voids could sharpen our search for new physics. Could they reveal subtle effects of dark energy? Could they expose cracks in our models of gravity? Could regions of extreme emptiness preserve signatures from the infant universe that crowded regions have long since erased? These are not small questions. They reach into the origin of structure itself, into the first moments after the Big Bang, and outward toward the possibility that our cosmic theories remain incomplete. And that is why the Boötes Void feels so haunting. It is silent, but not mute. It speaks through scale, through absence, through the unsettling beauty of a region where the universe seems to hesitate. In its darkness, we see not nothing, but a frontier, a reminder that knowledge does not end where matter thins out. Sometimes it begins there. Somewhere beyond the last bright galaxies, beyond the walls of the cosmic web, the void waits, vast, patient, and untouched by time. Perhaps that is its deepest lesson. The universe is unfinished in the human mind. There are abysses we have mapped but not understood, silences we have measured but not decoded, and mysteries so large that they make our greatest answers feel like first steps into the dark.